Laser systems. First one, Ruby laser. The first successful laser was fabricated by Meyman in 1916. It is a 3-level solid-state laser. Its main part is a ruby rod whose ends are flat, with one of the ends is completely silvered and the other is partially silvered. Ruby is a crystal of aluminum oxide Al2O3 doped with approximately 0.05% of chromium ions in the form of Cr2O3, so that some aluminum atoms in the crystal lattice are replaced by chromium ions. The pink color of ruby is due to the presence of chromium ions. The length of the ruby rod is an integral number of half wavelength of the laser light, so that the radiation trapped in it forms an optical standing wave which will stimulate the induced emission. The ruby rod is surrounded by a glass tube. The optical pumping is achieved by a helical xenon flash lamp surrounding glass tube containing the ruby rod. The characteristic energy levels of chromium ions are shown in figure below. The lifetime of the atoms in the energy level labeled as E3 is of the order of 10 raised to minus 8 second, whereas that at the metastable state E2 is about 0.003 second. The chromium ions are excited from the ground state E1 to the state E3 by absorbing light of wavelength 550 nanometer from the xenon flash lamp. Since the lifetime at E3 is very small, the ions quickly undergo non-radiative transition and fall to the metastable state. When the number of ion in the level E2 is greater than the number of ion in the level E2 is greater than that of E1, the population inversion is achieved. Then the photons of wavelength 694.3 nanometer produced by a spontaneous decay of some chromium ions, which are reflected back and forth between the silvered ends of the ruby rod and stimulated other ions to radiate. As a result, a large pulse of monochromatic coherent red light is emerged out through the partially silvered end of the rod. Once all the chromium ions are in the metastable state have returned to the ground state, the laser action stops. It is then necessary to send one more flash of pumping radiation from the xenon tube. Thus, the ruby laser operates in pulses. Spiking of a ruby laser. The output of a pulsed ruby laser is found to consist of a series of pulses of duration of a microsecond or less. Duration of an individual spike is of the order of 0.1 to 1 microsecond, and the time interval between two adjacent spike is about 1 to 10 microsecond. The power of each spike is of the order of 10 raised to 4 to 10 raised to 5 watt.